We want to set up the LCD using ATmega32 microcontroller and C language and vision code functions. We also use Proteus to simulate. Let's first look at the components of the project. The dot matrix LCD units, with built-in controllers. Microcontroller to display alphanumeric characters, symbols. The LCD unit has two 8-bit registers, an instruction register, IR, and a data register, DR. The IR stores instruction codes. The IR can only be written from the MPU. The data register is used for temporarily storing data during data transactions with the MPU. When the busy flag is set at a logical 1, the LCD unit is executing an internal operation and no instruction will be accepted. The address counter generates the address for the display data RAM and character generator RAM. This 80x8-bit RAM stores up to 88-bit character codes as display data. The character generator ROM generates 5x8 character patterns from 8-bit character codes. This RAM stores 8 arbitrary 5x7 matrix character patterns, as programmed by the user. The HD44780 can send data in either two 4-bit operations or one 8-bit operation, thus allowing interfacing with 4 or 8-bit MPUs. For 4-bit interface data, only 4 bus lines, DB4 to DB7, are used for transfer. Bus lines DB0 to DB3 are disabled. Bring the required components from the library. ATmega32. An LCD with 2 rows of 16 columns. Potentiometer. Follow the default connection of CodeVision, connect the LCD to port A. CodeVision functions support 4-wire communication. Connect the pins according to the datasheet and the 4-bit connection. The power supply is 5 volts, and the 15 and 16 LCD pins are hidden in the Proteus. Create a new project in CodeVision. Select the ATmega32 microcontroller with an internal frequency of 1 MHz. Go to the Alphanumeric LCD tab and enable LCD. The LCD model and the number of columns are important. Based on these assumptions, communication was established in Proteus. Generate and save the project. Let's delete application lines, which are not related to this project. Include the LCD driver routines. Initializes the LCD module, clears the display and sets the printing character position at row 0 and column 0. The numbers of columns of the LCD must be specified, 16. No cursor is displayed. This is the first function that must be called before using the other high-level LCD functions. Clears the LCD and sets the printing character position at row 0 and column 0. Sets the current display position at column X and row Y. The row and column numbering starts from 0. Displays the character C at the current display position. You can type the character directly. Compile the program. Give the hex file to the ATmega32. Character display on LCD is not stable. The problem can be solved by using delay. Compile the program. In fact, the character code A is sent to the LCD by the micro. The character code A is the number 65. In LCD, the standard character code is defined in the CG-ROM. And the LCD displays the character equivalent of the number 65. How to display an expression on the LCD. This function displays at the current display position the string str, located in RAM. This function displays at the current display position the string fstr, located in flash. How to display numbers on the LCD. We define ni as the integer variable, and nf as the float variable. We define two new string variables, tni and tnf. There are functions for displaying integers and floating point numbers. This function converts the integer ni to characters in string tni. In C language, the variable name of a string is a pointer to that string. This function converts the floating point number nf to characters in string tnf. The number is represented with a specified number of decimals. Let's show the integer in the first line and the float number in the second line. This file must be included before using the functions. You can send instruction to the LCD. Let's use help of CodeVision. Search for LCD. Get help from the table of instructions in the datasheet. The command code for turning on the crossover is E-hex, and blinking is F-hex. How to display a personal character on LCD. The CG RAM block allows you to use 8 personal characters. We use the 5x7 character model. You can get use from the program available in help. After this command, you can use from byte instead of unsigned char. A string where a new character is stored, arrow character. The define_char function puts the user character in CG RAM. Char_code can be a number between 0 and 7. The CG RAM address starts at 40 hex and each character occupies 8 bytes of memory. The for loop puts 8 bytes of the character in CG RAM using from the function, LCD_write_byte. Therefore, each time the function define_char is called, a character is placed in CG RAM. These program lines put the char 0 in CG RAM, and display it after displaying the expression user char 0. Let's display a rotating motion on the LCD with 5 characters. Define characters 0 to 4. Run the define_char function 5 times to load the characters in CG RAM. Now, display the characters with the code 0 to 4 in the 0 position with a time interval. The variable t specifies the amount of delay. Character 0. Character 1. Character 2. Character 3. Character 4. 200 millisecond delay. If you are interested in the topics of this channel, do not forget to subscribe. Thanks for watching.